Beneath the forests and the high desert of Central Oregon, something is happening that has puzzled the scientists who study the Earth for the better part of 2 decades. The ground itself is rising, not violently, and not in any way that a person standing directly on it could ever notice, but steadily, persistently, a slow swelling of the land across a broad region, as though something deep down below were pushing steadily upward against the crust. It is one of the strangest and most closely watched geological features anywhere in the country, a great bulge in the earth that has been growing quietly and persistently for years, spreading across a region larger than many people would ever imagine, and while scientists have theories about what is causing it, there remains a genuine and unsettling degree of mystery about exactly what is going on down there, how far it will go, and what, if anything, it might eventually mean for the people who live nearby. This is the story of that rising ground, of what the scientists think is happening in the hidden depths beneath it, and of why, for all of their sophisticated instruments and hard-won expertise, they still cannot say with complete certainty what the Earth is really doing down there under Oregon. To understand why this is so remarkable, you have to understand how it was discovered, because it is not the kind of thing anyone stumbles upon by walking across a field. The uplift is so gradual, so spread out across such a large area, that no human being could ever perceive it directly. It was found instead through the precise measurements of satellites, using a technology that can detect changes in the elevation of the ground to within fractions of an inch across vast stretches of terrain. When scientists compared measurements taken years apart, they noticed something that did not fit. A large region of Central Oregon had risen measurably, the ground lifting up and abroad. Gentle domes centered on a remote and sparsely populated area. The center of the bulge had risen by inches over the span of years, a rate that sounds tiny until you consider that it is happening across an enormous area and that it has continued, year after year, without stopping. Something was inflating the land from below, and the scientists set out to understand what. The leading explanation, and the one most scientists consider most likely, points to molten rock deep beneath the surface. The region of Oregon where the uplift is centered is volcanic country, part of a landscape shaped over millions of years by volcanic activity, dotted with the remnants of ancient eruptions and the cones of long, quiet volcanoes. In such a place, it is not surprising that the forces at work would be volcanic in nature, and the most widely accepted theory holds that the uplift is caused by magma, molten rock, accumulating in a reservoir several miles below the surface. As the magma collects in this deep chamber, the theory goes, it pushes upward and outward on the rock above it, and that pressure is transmitted all the way to the surface, causing the broad, gentle doming that the satellites have detected. In this view, the rising ground is essentially the surface expression of magma slowly gathering far below, an underground pool of molten rock swelling and lifting the crust above it, like a blister forming under the skin. If that theory is correct, then what is happening under Oregon is a glimpse of one of the fundamental processes by which volcanic landscapes are built and maintained over enormous spans of time. Magma does not simply erupt out of nowhere. It accumulates, slowly, in reservoirs deep in the crust, and over thousands or millions of years these accumulations can grow, shift, cool, or eventually feed eruptions. The uplift in Oregon may be a rare chance to watch this process unfold in real time, to observe magma gathering beneath a landscape in a way that is usually invisible and unfolds over timescales far longer than a human life. That alone makes it scientifically fascinating, a natural laboratory for understanding how the deep plumbing of a volcanic region actually works. But it also raises the obvious and slightly unnerving question that anyone would ask upon hearing that magma is pooling beneath the ground. Does this mean a volcano is going to erupt? And here is where the honest answer becomes genuinely important, because the temptation to leap from magma to eruption is strong, and it is largely mistaken. The accumulation of magma at depth does not mean an eruption is coming, at least not in any time frame that matters to the people living their lives above it. Magma gathers beneath volcanic regions all the time without erupting, sometimes cooling and solidifying in place over thousands of years, sometimes sitting quietly for immense spans before anything happens, sometimes feeding eruptions only after periods so long that they dwarf all of recorded human history. The presence of magma several miles down, slowly inflating the crust, is a normal feature of a volcanically active region. And by itself, it is not a sign of imminent danger. Scientists who study the Oregon uplift have been consistent and careful on this point. The rising ground is not a warning that an eruption is about to occur, and there is no indication that anything dramatic is going to happen anytime soon. The bulge is being watched closely precisely because it is interesting, and because monitoring it is prudent. Not because it is dangerous, but if the magma theory is the leading explanation, it is worth being clear that it is not the only one, and this is part of what keeps the mystery alive. Scientists have considered other possible causes for the uplift, because the Earth is complicated and the movement of the ground can have more than one source. Some have wondered whether the movement of water deep underground through the porous and fractured rock of the region could play a role, whether the pressure of fluids moving through the crust might contribute to the swelling. Others have considered whether tectonic forces, the vast and slow movements of the pieces of the Earth's crust, might be involved. Given that this part of the world sits in a geologically active region where the great plates of the Earth grind and shift, the truth is that while the magma explanation fits the observations well and is favored by most researchers, the Earth's interior is fundamentally difficult to observe directly, and there remains real uncertainty about the precise mechanism. Scientists cannot simply drill down several miles and look. They have to infer what is happening from indirect measurements at the surface. And those measurements, precise as they are, do not tell the whole story of what is unfolding in the dark, hot depths below. It helps, too, to understand just how unusual it is to catch a feature like this in the act. Volcanic landscapes all over the world bear the scars and monuments of magma that once gathered beneath them, ancient chambers now cooled to solid rock, calderas left behind by eruptions long past, domes and cones and lava flows that record events finished thousands or millions of years ago. What we almost never get to see is the process while it is actually happening. The slow accumulation of molten rock in the moment of its gathering, because it unfolds so slowly and so deep beneath the surface that it typically escapes notice entirely. The Oregon uplift is a rare exception, a case where the timing and the technology have aligned to let scientists observe a deep geological process in progress rather than reconstructing it from its aftermath. This is part of what makes it so valuable and so closely studied. It is not merely a curiosity, but a rare window into the machinery of a volcanic region, a chance to test and refine our theories about how magma moves and gathers in the crust against a real, living example unfolding in real time. For the scientists who study these things, that is an extraordinary gift, however much uncertainty comes bundled with it. The scale of the feature is also worth appreciating, because it is far larger than most people imagine when they picture a bulge in the ground. This is not a small mound or a localized hump, but a broad, gentle swelling spread across an enormous area, so vast and so gradual that its curvature is utterly imperceptible to anyone standing on it. If you were to hike across the very center of the uplift, you would see nothing unusual at all, just the ordinary landscape of Central Oregon, the pines and the volcanic rock and the high desert stretching away in every direction. The rising is spread so thin across so wide an area that it amounts to only a slight tilt of the land. Detectable only by instruments capable of measuring elevation, changes finer than the width of a finger. And yet, integrated across the whole vast region, that slight rising represents an enormous movement of material below, a redistribution of mass deep in the crust on a scale that is genuinely difficult to grasp. The gentleness of the surface expression belies the magnitude of what is happening underneath, and that contrast between the imperceptible swelling above and the immense forces below is part of what gives the phenomenon its strange power. This is the heart of why geologists cannot fully explain the Oregon uplift, and it points to a humbling truth about our knowledge of the planet we live on. We know a great deal about the surface of the Earth, which we can see and walk upon and measure directly, but the interior, the vast realm of rock and heat and pressure that lies beneath our feet, is almost entirely hidden from us. We cannot see into it. The deepest holes humans have ever drilled barely scratch the outermost skin of the planet. reaching nowhere near the depths where the magma beneath Oregon is thought to reside. Everything we know about what is happening down there, we know indirectly, by measuring the way the surface moves, by studying the vibrations of earthquakes as they pass through the deep rock, by analyzing the chemistry of the materials that eruptions bring up from below. It is a bit like trying to understand the inner workings of a sealed machine by watching how its outer casing flexes and listening to the sounds it makes. We can learn an astonishing amount this way, but there will always be a residue of uncertainty, a gap between what we can measure at the surface and what is actually happening in the hidden depths. The Oregon uplift sits squarely in that gap, and that is what makes it so compelling. It is a place where the Earth is quite clearly doing something, where the evidence of movement is unambiguous and measurable, and yet the underlying cause remains partly obscured. The scientists watching it are in the position of detectives with a clear set of clues, but no direct access to the scene of the crime. They can see the ground rising, they can measure how fast and how far, they can map the shape of the bulge and track how it changes over time, and from all of this, they can build a compelling case that magma is the culprit. But they cannot prove it beyond all doubt, and they cannot rule out that other forces, or some combination of forces, are at work. The mystery is not that they have no idea what is happening. It is that the Earth guards its deepest secrets well, and even the best science can only see so far into the dark. It is worth dwelling for a moment on how the uplift is monitored, because the effort to keep watch on this rising ground is itself a remarkable feat of modern science. The satellites that first detected the bulge continue to measure it from orbit, comparing radar images taken over time to map the swelling of the land with extraordinary precision. On the ground, networks of instruments track the tiny movements of the surface and listen for the faint tremors of earthquakes that might reveal the movement of magma or fluids below. Scientists watch for any change in the pattern, any acceleration in the rate of uplift, any swarm of small earthquakes, any of the signs that would suggest the situation is evolving. So far, the uplift has been remarkably steady, continuing at a slow and consistent pace without the kind of dramatic changes that would raise real alarm. This steadiness is itself reassuring, because a volcanic system moving toward an eruption typically shows signs of increasing unrest, escalating earthquakes, and accelerating deformation, and the Oregon bulge has shown no such escalation. It is rising, but it is rising quietly, in a way that suggests a slow, deep process rather than an impending crisis. Still, the monitoring continues, and it should, because the responsible course when the Earth is doing something you do not fully understand is to watch it carefully. The scientists studying the Oregon uplift are not sounding alarms, but neither are they ignoring it. They are doing exactly what good science demands, keeping a patient and vigilant watch, gathering data year after year, refining their models, and standing ready to notice if anything changes. This is the unglamorous reality of monitoring the Earth, a long, quiet vigil over a process that unfolds on a timescale far slower than the news cycle. Punctuated by no dramatic events, but sustained by the knowledge that understanding these processes matters, both for science and for the safety of the people who live in these landscapes. The value of the vigil is not that it expects catastrophe, but that it ensures we will not be caught unaware if the situation ever does begin to change. It is also worth understanding what an eruption in this kind of setting would and would not look like, precisely because the fear of one is the first thing that comes to mind when people hear that magma is gathering. The volcanic history of this part of Oregon is not, for the most part, a history of the sudden, explosive. Mountain-shattering eruptions that people associate with the most violent volcanoes. Much of the region's volcanism has been of a quieter, more effusive character, producing flows of lava and the gradual building of volcanic landforms rather than cataclysmic blasts. This matters because it shapes what the realistic range of possibilities actually is. Even in the extraordinarily unlikely event that the magma beneath the uplift were someday to feed an eruption, the most probable style of such an event, based on the region's geological character, would not necessarily be the kind of continent-altering catastrophe of popular imagination. But it bears repeating, as emphatically as possible, that no eruption is expected. That the uplift shows none of the signs that would precede one, and that this discussion of what an eruption might look like is a thought experiment about a remote possibility, not a forecast of anything that is going to happen. The scientists are unanimous and clear that the rising ground is not a sign of an imminent eruption, and nothing about the way it is behaving suggests otherwise. It is a natural question to ask how this feature compares to other places around the world where the ground is known to rise and fall over volcanic reservoirs, because Oregon is far from unique in this respect. There are places on Earth where the land has risen and then fallen again over the course of years or decades, swelling as magma or fluids gather below, and then subsiding as the pressure eases, sometimes cycling back and forth without ever producing an eruption. There are great volcanic basins that have inflated and deflated many times over their long histories. Breathing slowly, like some vast geological lung, their restlessness a normal part of their existence rather than a march toward disaster. Seen against this global backdrop, the Oregon uplift looks less like an anomaly and more like one instance of a widespread phenomenon, the ordinary restlessness of a volcanically active planet. This context is reassuring, because it means scientists have many other examples to compare against, many other cases in which similar uplift occurred and did not lead to catastrophe, and that body of experience informs their calm assessment of what is happening in Oregon. The rising ground there is unusual, mainly in how clearly and precisely it has been measured, not in the fundamental nature of what it represents. To put the Oregon uplift in perspective, it helps to understand that the Earth is full of such slow, mysterious movements, and that the ground beneath us is far less solid and permanent than it feels. We tend to think of the land as the very definition of stability, the fixed and unchanging stage on which our lives play out. But the Earth is a dynamic, living planet, its surface constantly, if imperceptibly in motion, rising and falling, stretching and compressing, driven by the immense forces of heat and pressure churning in its interior. The continents drift, the mountains rise and erode, the ground swells and subsides in countless places around the world, most of it far too slow for us to notice. The Oregon uplift is a particularly clear and well-documented example of this restlessness, a place where the normally invisible movement of the Earth has been caught in the act and measured with precision. It is a reminder that the solid ground is not so solid after all, that beneath the apparent permanence of the landscape, the planet is always at work, always moving, always changing in ways we are only beginning to understand. There is a natural human tendency, when confronted with a mystery like this, to imagine the worst, to picture the rising ground as the prelude to some cataclysm, a volcano building toward a devastating eruption that will one day burst forth and lay waste to the region. It makes for a dramatic story, and the language of a great bulge swelling in the earth certainly lends itself to alarm. But the reality, as the scientists patiently explain, is far less dramatic and far more interesting. The uplift is most likely a window into the slow, deep processes that shape volcanic landscapes over spans of time we can barely comprehend. A chance to observe the earth building itself in real time. The magma, if that is indeed what is causing the swelling, may never erupt at all, or may not erupt for tens of thousands of years, or may simply cool and harden in place, leaving behind a body of rock deep in the crust as a monument to a swelling that never became an eruption. The rising ground is not a countdown to disaster. It is a glimpse of geology in motion, a rare and precious opportunity to study a process that usually hides itself from view. That said, the honest acknowledgement of uncertainty cuts both ways, and it would be wrong to pretend that scientists can offer absolute guarantees about what the Earth will do. They cannot. The very fact that the cause of the uplift is not fully understood means that its future course is not fully predictable either. This is not a reason for alarm, but it is a reason for the continued careful watch that scientists maintain. The most likely future, by far, is that the uplift continues slowly for a long time and then eventually stops, or slows, or reverses, without any dramatic event ever occurring, as has happened with countless similar features around the world. The scientists watch not because they expect catastrophe, but because responsible stewardship of a landscape means understanding the forces that shape it, and because the only way to know if something is changing is to have been watching all along. The uncertainty is not a source of fear, but a spur to curiosity and vigilance, an invitation to keep studying a planet that still holds many secrets. What makes the Oregon uplift ultimately so captivating is precisely this combination of the measurable and the mysterious, the way it sits at the boundary of what we know and what we do not. It is real, undeniable, precisely quantified, a swelling of the ground that the instruments record without ambiguity. And yet its cause remains partly hidden, its future uncertain. Its meaning still being worked out by the scientists who study it. This is science at its most honest and most humbling, confronting a phenomenon it can observe but not fully explain, offering its best theory while openly acknowledging the limits of its knowledge. There is something admirable in that honesty, in the willingness of the scientists to say plainly that they do not know everything, that the Earth has surprised them and continues to keep some of its workings to itself. In an age when we are accustomed to having answers at our fingertips, the Oregon uplift is a reminder that some of the deepest questions about the very ground beneath our feet remain genuinely open. So something is indeed rising under Oregon, slowly and steadily. And the geologists watching it have a good idea of what is probably happening, but cannot say for certain. The most likely explanation is magma gathering in a reservoir miles below, inflating the crust in a broad, gentle dome, a natural process that has been unfolding for years and may continue for a very long time without ever producing an eruption. But the depths of the Earth are hard to read, and other explanations cannot be entirely ruled out, and so the mystery endures, watched over by patient scientists and their precise instruments. It is not a story of impending doom, whatever the drama of the rising ground might suggest, but a story of a living planet quietly at work, of the limits of human knowledge, and of the enduring capacity of the Earth to surprise us. The ground under Oregon will keep rising, for now, and the scientists will keep watching, and in that patient watching lies both the honest admission of what we do not know and the quiet confidence that, whatever the Earth is doing down there, we will be paying attention. The mystery of the rising ground is not something to fear, but something to marvel at, a reminder that even now, even here, the planet we think we know so well can still leave its most careful students genuinely, fascinatingly unsure. In the end, perhaps the most valuable thing about the Oregon uplift is the way it reframes our relationship with the ground beneath us. We spend our lives treating the Earth as a fixed and finished thing, a stable foundation that will always be there, unchanging and dependable. The rising ground under Oregon quietly corrects that assumption, revealing a planet that is still forming, still restless, still driven by forces that were shaping the world long before we arrived and will go on shaping it long after we are gone. To stand on that landscape and know that it is slowly swelling from within, pushed upward by processes miles below that we can measure but not fully explain, is to feel something of the deep time and deep power that the Earth embodies. It is a humbling and a wondrous thing, and it asks of us not fear but attention, not panic but a patient, curious watchfulness. The scientists will keep watching, the ground will keep rising for now, and the mystery will endure a while longer, a small and fascinating uncertainty in the vast and ancient story of a living planet that has never once stopped moving.